to, it is still streaming. Yeah, the recording has started.
Okay, cool. Then
Okay.
I will quickly say something, and you want to say something as well afterwards? Yes, so do you want to start?
Yeah, I'll just say thanks
Yeah.
to everybody. Thanks to you. Okay. Hello, everybody. Good evening, good afternoon, good morning, wherever you are located in the parts of the world. It's our great pleasure to meet you all. First and foremost, I thank Professor Ajit Jaokar and his team for taking the responsibility of such a wonderful initiative, which has been his last two cohorts and last two workshops were also highly useful to many people, and I am sure it will be useful to all of you. Garze Marathi Global is a non-profit organization registered in India as well as in California, San Francisco, California. Our main principles are to share knowledge and experience, and persons like stature of Ajit Jaokar has contributed immensely to that. My role in this entire workshop is nothing beyond just organizing and initiating the emails, and that's all. Rest all is handled by very graciously, very kindly by Professor Ajit Jaokar. So with those few words, I wish you all the best. And from here, the only thing which Garze Marathi normally expects, Garze Marathi gives everything free of charge. Ajit Jaokar is also not charging anything, but only with a small expectation that you will be giving forward to. With those words, I take Ajit's and your permission to sign off because I don't want to be a disturbance in a classroom. So Ajit, thanks a lot. Please take
Thank
over.
you.
And with your
Thanks.
permission, I'll sign off. Namaste.
Sure. Thank you. Thank
Yeah.
you. Thank you. Welcome, everybody. And
Okay.
thank you, Anand. And thank you, Garje Marathi. So I've got to admit a few people as they come through. Thank you, Anandji, very much for the introduction. And as Anand said to us, that this is a mixture of two groups. The first group is a social organization called Garje Marathi, which is based as led by Anand, and I have also contributed a few things to their work, as he said. This is based out of San Francisco and India. And the second group is my newsletter. And in both cases, the objective is the same, that we are going to conduct an AI mentoring workshop. And it's actually modeled on the work I do at Oxford. So I was very nicely, two of our team have volunteered to help out at Oxford. So I'm just going to have to mute. If you just mute everybody, if you just mute yourself, ideally, with that. Um, this is run on the structure of Oxford, and I will explain to you the first things, everything, how it goes. The most important and the first thing is you need to have joined Slack. Yes, because the Slack is where we are sharing the code. So I uploaded the code about 15 minutes ago, and I uploaded the slides there as well. So hopefully you should have access to everything from there. Yes, because I think that's the format we are going to use with that. And today we are going to run the session so that we have a break at around 4 o'clock. That is 1 hour from now, about a 5-minute break. And then at around 5 o'clock, Aisha will take over for the coding session. So that will be something where we will give you some code. We will ask you to do something. You can go away for about 15-20 minutes and come back and then share some more things with that. And the main thing is that most of this will be very interactive. And in Oxford as well, we keep the sessions extremely interactive. And I'll tell you why that is the case. And that is how you would learn the majority, a lot from this particular course. As usual, the recording is being on. So what I'm going to do now, I'm going to share my screen. Yes. And then we are going to start. And I will, of course, stop and take questions very soon as well. So here we go. First of all, I want to see, do you see my screen? Yes?
Yes, yes.
Oh, very good. Perfect. Yes. So welcome again. And so this is an AI mentoring workshop run by two organizations, which is Garje Marathi and Finite. And so this is what we are going to do for the next 8 weeks with this. Now, unfortunately, I have a problem now because when I go full screen, I don't know how to admit people now. This is a problem I did not anticipate. Aisha, can you admit people? Yeah, this is the problem. Sorry for this. What seems to be happening is that, yeah, see, because I now need to Sorry for this. Yes. So I need to admit people, otherwise people are going to. Aisha, can you admit
Wait,
people?
sorry, yeah, I was muted. Yes, I will do that.
Okay, good. That's fine. Then I don't need to stop for that. Yes. So
Yeah.
I'll continue the presentation now so that you can admit people as that. Otherwise, I'll have to stop physically. And when I'm
Yes,
in the
sure,
full
no
screen,
worries.
I don't see anything. Yeah, with that. Thank you for that.
Okay.
Cool. Yeah. So very good. So we are welcome to the AI mentoring session. And as I said, we'll take a 5 minute break after about an hour, and we'll keep it very interactive anyway. So first of all, a bit of introductions to people who don't know me. My main thing, what people know me, is for my work at Oxford, where I teach AI with a very specific course, which is a full stack AI course. It's very comprehensive, and we have been very successful worldwide in sort of scaling that and talking to people with that. Outside of that, I also run my own company, which is Fine Labs, and I am the chief AI officer of a German company called Digity, and I am on the board of a cybersecurity company called Castellium in New York. So I'm also a professor at the Johannesburg Business School for AI, and on the board of the Johannesburg Business School, which is actually not here at the moment because it was just announced last week. So I have a very broad background in AI. And of course, we have a very good team. And this time, when I tried to do this, this is quite an ambitious idea to run something for 8 weeks like this. But I felt that if you wanted to do it properly, we want to do it like that. And I'm very grateful for my team, Aisha Mutlu, who is online here now. So Aisha is originally from Turkey, and Marina, who also may be online next week. She's originally from Russia. And Kautar, who also I think will be online, is based in France and Morocco. So it's a pretty much of a global team, and Aisha and Marina are a part of my core Oxford course, and Kauthar is hopefully finishing her PhD in AI in France. So we have a very strong background in terms of sort of how what we do. The Slack is very important. Just make sure you join the Slack because that avoids me sending emails, especially because there are two distinct group of people who I don't have everybody's email address. This is very important. The people who I have email addresses are only from my newsletter. So that the second group of people, so to avoid that, be on the Slack so that everything will be there and all the code will be there. At the moment, all these slides are on Slack. Also, the code is on Slack, and Ashley will talk to you about that very soon as well. This is just to remind you that in the resources channel on Slack, we have the code. And also there is a channel on Slack called Questions for Tutors. In that, if you ask questions relating to the sort of the coding and stuff like that, we will make sure we answer it within the week for sure. And a lot of this will be based on the questions you will answer, questions you will ask, because the subject is very complex and very vast. But I think what we are trying to do is make it more concise so that you can learn a lot in a relatively short time. This is the same strategy I use at Oxford. And also, more importantly, people are diverse, meaning they come from a different background. And to emphasize a couple more things, English is the language of communication. My core team is mostly from Oxford. This is the charity, so there is no cost. The code we have already started uploading, but the majority of the code will be there next week. All the sessions will be recorded. The videos will be accessible in a password protected site externally also for people as they put it on their site. If you are under 18, please let us know. I do know people who are under 18. They are normally accompanied by somebody who is an adult, just to be sure that for safety reasons with that. Obviously, normal decorum conditions apply. This is a complex topic. It's a very immersive topic, but we have very good experience teaching this at Oxford. And there will be a book relating to this. If you are interested in the book, we will share it with you at no cost as well if you complete this whole thing. So this is the whole idea of sort of engaging with people like that. And also, like I said, keep it interactive, keep asking us questions. Also on the Slack, we will answer them all within a week. And most importantly, this is not associated with any particular organization, especially ones which I'm associated with, and especially not Oxford. So this is entirely a personal venture and a charity in that sense. One final thing was the exact sequence I will let you know by next week, but I will generally try to go slow first. This is very important because of the diversity of the group. I need to understand who is there and how they are engaging and how people are reacting. I will try to include as many as people as possible through our work. And when I say I also mean our whole team. So this is generally our sort of intention. And maybe after the first 4 weeks, we could speed it up a lot more. In the first 4 weeks, my plan is to make sure that we try to cover at least the classification code, the regression code, and one deep learning algorithm. So if we are able to do that much by the first 4 weeks, I think, and the concepts, of course, because we'll spend a lot of time initially trying to understand what exactly we are trying to do. But from today onwards, you will start coding, meaning you will start something. So Aisha will start presenting you something which we encourage you to start doing, and Aisha will explain to you how those libraries work and so on and so forth. So this is right from the beginning, you start coding with that. I've already explained who the team is: Ajit, Aisha, Marina, and Kautar. And you will see them on and off. So Aisha is with us already today. There's also supporting team. Alexa is also on the supporting team today. Aditya Bhaskaran and Malhar Bhede are our core team who are also supporting us in this venture. Okay, so let me start off now with the actual content. Does anybody have any quick questions before I start?
Yeah, we can't see the Slack channel.
Yeah.
We can't see the resources in Slack.
Yeah, same here, Ajit. Santosh here.
I don't know. Aisha had the same. So if you go to the general channel, maybe I'll invite you on there. Aisha.
Sorry, I will just add some more thing.
No, just click on the Slack channel on the conversations that has been going on. You should be able to get onto the
Yeah. So if you go to the general
resources
channel,
as well as
if you
question
go to
channel.
the Aisha, maybe we can do that in the general. You can see the general channel, yes, everybody.
Yeah, we can see general, but not the general and workshop. We
It
can see.
doesn't appear there. So in the general, sorry, can you hear me?
Yeah, I can hear you.
Yeah. So if you go to the general channel chat, and there are two hashtags there, one for question for tutors and one for resources. Just in the chat, can you click on the hashtag and can you join the channel so that it will also be under your Teams channel, Slack channel. So just click on the.
Or you know what, Aisha, if you go to the channel and add everybody to it, that could be another way of doing it.
Okay, let me have a look.
Yeah. If you can do that, go to the resources channel and let's add everybody to it. I think because by default it doesn't get added. I think you also had the same problem with that.
Yeah.
But anyway, just to be sure that if you go to the general channel, you will see the chat there. And in the chat, if you just click on the hashtag with that, in fact, let me do this right now, actually. Let me, I'm presenting a particular window, so it should be fine. So I can go to the Slack channel and I will go to the general and I will put the channels here, hashtag resources and hashtag for tutors. So what I've done now is I've gone to the, Aisha's done the same thing as well. And okay, thank you. Who is this? Who's hosted? Yeah, this is Magano. Thank you for this. So you should be able to see it, but I have also put the tags themselves in the chat. If you just click on them in the general channel, you should be able to see them. Cool. Okay. So now I'm going back to the presentation. So everybody's happy with that? Yeah. Cool.
Yes.
Good. Okay. So now I'm going to actually start.
Sorry, I have a question. Sorry.
Yeah. Go on.
It's if some week we can participate directly, we can just if we had to skip that week, we can see the other the lesson, the skip lesson after it.
Yes, you should be able to, because we have a recording. We are fully recording everything. So yes, it shouldn't be. You should be able to do that. I will let you know where the
Okay,
recording
thank you.
is after this, because that will be on because I'm not running the Google Meet, but it should be fine. That shouldn't be any problem in terms of that. Cool. Okay. Very good. Let me just see here. Let me come back here. Let me just close my video so that it won't have it. Okay, good. Any more questions on this so far? Good. If there are no other questions, then I will start with the actual presentation. Yes. And now I'm actually going to start the teaching here. Let me just see slide. Okay. So let me start with this. So like I said, this is the place in Oxford, and sorry, yes, Aisha, were you saying? Okay, sorry, I thought it was. So this is a place in Oxford, and we use this quite a bit. And once Aisha and I were having coffee there, and we saw this couple next door to us, next table to us, and they were discussing about Schrodinger's cat. Schrodinger's cat is a quantum mechanism concept. And the point there was like what we were talking about, what we think about is a place like Oxford, what actually is happening is normal people discuss about normal cats, but people here would discuss about Schrodinger's cat. The point about the conversation is that the quality of the conversation and nature of the conversation is very high in a place like this. And this is really where I think what distinguishes a place like that from other places, because I think that in many ways, being a part of, sorry, you have to mute yourself, whoever it is. Yeah. So being a part of this is what we are trying to do, and this is the same philosophy here. We are trying to create a conversation. I will spend a lot of time, even in my teaching, I spend a lot of time interacting with people, and I think that slowly you will see this, but that's what will make a big difference, especially as we are going to get into a lot of complex code within that. We're also very strong on diversity and inclusion, both at Oxford and both here. So we have a very strong female-led team, as you can see, and also with my own personal sort of background. As many of you know, I've been quite open about being on the autism spectrum, etc. So we're quite keen to include as many people as we can in the conversation. And remote teaching is quite complex, but surprisingly enough, we have done very well with it, again, through Oxford. So we have very good experience of remote teaching within that. And the next thing is, of course, that when you think about AI, there is a concept called the imposter syndrome, meaning that you never know enough about it. And every time you feel that you don't know enough, and I think this is very normal in something like AI, and you always feel like you are a beginner, no matter what you do. And I think we accept that the spirit of learning, and this is also what we do. So everything will be new and everything will be complex, but it is not something to worry about. Everybody goes through that, and including us at this point. So the other thing is, AI is, you can go through it at many levels. So we will be going quite a bit deeper into some of these things. Again, the idea is we start with a broad structure and then explore it deeper into understanding how things work. And this is quite intentional within that. Now I'm going to start with some definitions, because those definitions are quite important. The first one is machine learning is the idea of explicitly training an algorithm. Yes, you train an algorithm with data. The second one is deep learning, is the definition, excuse me, the definition for that is automatic feature detection or representation learning. This definition will make no sense to most of you at this point, but it is an important definition. We will come back to with that. The third is artificial intelligence, is machines that can think and reason, which are based primarily on deep learning algorithms. Narrow artificial intelligence is what we are seeing today, that is AI applications in a specific problem. General AI is what we are not seeing today, which means that you can apply AI in any context. The best example I can give you from sort of media and culture is the Terminator movie, where you have this Arnold Schwarzenegger character, which is an android-like character, which sort of comes to Earth and is fully functional in the human society. Therefore, the character can solve multiple problems at any time. This is not the case with AI at the moment, and this is why these definitions are important, because machine learning and deep learning is what primarily what we'll be doing. And those two are, there are a number of algorithms under machine learning and deep learning. And by next week, we will explain to you which algorithms exactly we will be covering over this period of time. Excuse me. But we'll be covering, when people say that they do AI, they are doing typically, they have the capacity to do machine learning and deep learning algorithms and using some sort of coding. In our case, that is going to be Python using the TensorFlow library, which Aisha will start to introduce you today. So this is what I mean by it's a very hands-on course and very much understanding of what we are trying to do within that. So it involves AI, and this is the meaning of AI in this context we're talking about. So if we look at the general pipeline of what you mean by learning from data. So when you learn something from data, you have effectively what is called training data. And on the training data, you train an algorithm to build a model. The word model is an algorithm plus data. Yes, so that is how you train the model. And then you predict something based on input data which you have not seen. So this is the general flow of typically most algorithms. There are some exclusions to this, of course. There is unsupervised learning, which doesn't follow this format. But for now, let us say that we are talking about typically training data, have a data set on which you train a model. That means a model is an algorithm plus data on which you then make a prediction for data which you haven't seen before. So obviously that the new data shouldn't be a part of your training data, because that means it's like you haven't seen it before. So it's like learning to drive a car. Yes, so you learn to drive a car on a specific road, and once you have learned that concept, you hopefully are able to drive on any road, and then function independently of that. So think about it like your training data as a place where you learned, and then you went out there and saw something new, and you were managed to sort of take those learnings from the training and then abstract them onto a new situation. So this is generally the phenomena what you're seeing with machine learning and deep learning algorithms. We'll come back to the difference in what they are, but for now, this general flow is valid. Now, when you come to deep learning, there is a specific thing here. So deep learning algorithms are typically employed into areas where you have unstructured data. Yes, so unstructured data means pictures, video, that type of stuff. So you're seeing things such as you train the algorithm using pictures of cats and dogs and skunks in this case, and you train the model, which is so that you have trained the model such that it is able to recognize a picture of a dog or a cat or something like that. Then you deploy the model, then you show a picture of a dog, which is the one on the left hand side, bottom left, and it shows you a classifier that this is a dog, correct? So this is a neural network. It is a deep neural network. So this is a deep learning algorithm, but functionally it is doing exactly the same thing as what we saw here. Yes, so yes, you have training data sets, you have an instance, and you have a deep learning approach, but the block diagram is still the same. Yes, you are training it using some data, using label data. Label data means that when you train it using data, you say that this is a cat or a dog, but when you deploy it, you don't say what this is. It is able to recognize what that is. Yes, so this is more than, of course, detecting cats and dogs. Think about tumors, for example, that you have a tumor which is cancerous or not. You have X-ray, which is COVID or not, and examples like that. So you train it using all the examples of labeled COVID data so that it sees it the next time. It can say that this is a bad situation or a good situation in that situation. So this is generally the philosophy of sort of starting to work with that. A little bit more complex, a little bit more terminology is that you have the word inference here. The word inference means the same thing, which means that you see the new data here and you are able to see something here. The only difference between this diagram is it talks a little bit about the connections in the neural network. So it's a trained model which is trying to show you that these neural network connections are created using the training data set, and the next time you see something new, you're able to see something with that. But by the way, this is something we are going to do in real code. Yes, so this is not just talking, and this is why this becomes quite important. But it's very important to understand what is it you are trying to achieve with this. When you see it in Python, you will just see it as code. and you will just see it as a data set which you upload and run something, and which you will be doing at the end of 8 weeks as well. You'll be able to classify something as a particular category within that. Now let's look at some basic concepts of AI, ML, and this one. So the general principle is that what we are looking at is the algorithmic side of AI. Yes, so there are many things which are around that, but we are not looking at that. For example, there is cloud, which is what we teach in the course in Oxford. Then there is edge computing, which is typically IoT, and then there is a whole DevOps area. Then there's a data engineering, all that type of stuff. So there is a whole computer science sort of a framework around the core algorithmic stuff, but we are primarily focused on the AI, which is the machine learning and the deep learning. Yes. Now, okay, any questions on this so far? Let me just see, because I think I can stop this. I can stop presenting and keep here and take this. Let me do this now while we do this here. Let me see how this chat works. Is there a chat here? Yes, there is a chat. Okay, so okay, cool. Any questions on this so far? You can actually unmute yourself and ask. And so sorry, Faraz, can you see? Okay, sorry, yeah, so this is regarding, so yeah, please go ahead if anybody has any question. Yeah.
So when you talk about neural networks,
Yeah.
are you basically saying it's an implementation of AI?
Yes, so this is a good question. So basically, when I say neural networks, I'm saying that it is a mechanism to implement a deep learning algorithm, which is a part of AI. But I will come back to that in a lot more detail with that. But the short answer is neural networks are modeled on the brain, the human brain, and they are a mechanism to implement deep learning algorithms. The deep learning algorithms are a part of AI. Cool. Okay. Perfect. Okay.
Yes,
So,
sir. This is Shreya Desai, and I have one question related to some reinforcement learning. Also, I have heard along with supervised and unsupervised. So, can you just brief about it?
Yeah, we'll be coming to that as well. Yeah, we'll be coming to that definitely. So there is, I will explain that to you once we come back to that. But yes, so there is that as well. Very good.
Okay.
Thank you.
Thank you,
Yeah.
sir.
So Valoshan, yes.
Yeah, Ajit, thank you so much. I just wanted to find out, probably this is a question for later in the course. Would we be working on any cloud platforms, or is it just TensorFlow that we're going to be working on?
We are going to be working on TensorFlow, but what was your question? Would we be working on a cloud platform?
Yeah, so are we going to be using like any pre-built AI platforms in AWS or Azure?
No. We'll be using Google Colab, which is a very easy way to run Python code without downloading anything, and that's the sort of the cleanest way I can get people up and running without having them to install anything or going to a cloud platform, etc. So that's why I'm trying to reduce the dependencies for people, considering that they come from different places.
Okay, perfect. But if we wanted to use the notebook in Azure or AWS, we could, right?
Yes, you could. There's no problem with that at all. We at Oxford, we use Azure. We also use Anaconda. So there's all sorts of things you could do. If you're comfortable with that, I don't have a problem with that. That's fine. Yeah.
Awesome. Thank you so much.
No worries. Yeah. Okay, cool. Any more questions on this so far? No, I think it's fine now. Yeah, if you post in the chat, I can see it as well. Yes, so I think that's another option to do that. But I just wanted to keep it interactive and sort of keep it, because I think that the interactivity, like I said, will be better, because at some point we know how to catch up with this stuff. But the more we interact, the better I know the sort of a gauge of what people are doing. And we will have a break in another 30 minutes for about 5 minutes.
Yeah. Ajit Mahadev here.
Yeah, hello, hi.
Yeah, I saw here the trained algorithm and untrained algorithm. For example, if you make this model can be used in any data set, right? For example, I work in the automotive. I have lots of GBs of the data like this one. So if you make any algorithm, that can be allocated to any other data, or maybe we need to do some creation for that.
So the way it works is that if you take a step back, so what we are trying to do is we have data from the data, we're trying to learn something. Yes. So for example, if I were to say that I'm trying to understand if people have got, if the tumor is there, which is cancerous or not, correct?
Mhm.
So the data is about the tumors, images of tumors, and it is saying, supposing they're skin pictures, and it is saying that this image is cancerous, this image is not cancerous, and therefore the data set applies to a specific problem, and then you can apply that to other instances of the problem when you have not seen it before. That's my point. Okay.
Okay, understood. Yeah,
Cool.
thank you.
Thank you. Perfect. Now I'm going back to my presentation. Yes. So now what we are going to do is, sorry, I started off from the beginning. Yeah, I shouldn't have. Well, typically, when people think about AI, they think about job losses, and all the media tends to hype up things, which is rather unfortunate because when you actually do these things, you find that they are very useful and they're not as scary as things. The main reason why people confuse AI is because they confuse the general AI with the narrow AI. So this is what people like Elon Musk and Bill Gates have been afraid of, is that when AI becomes sort of all powerful and makes decisions on our behalf, that type of stuff. Um, there is that concern which is being addressed quite strongly using explainable AI and all those things. But to a large extent, AI and machine learning and deep learning is a very specific type of solving problems based on data and based on algorithms. And both of them are moving very, very fast. So I guess what I'm trying to say to you is that many times these things become quite complex, but you don't need to worry too much about them. But this is an interesting concept. This is a diagram which says how far we are to modeling the brain of something. Yes. So we are at the moment, I guess, modeling close to the behavior of modeling a cat, the brain of a cat. And the idea is that by 2060, we could be model the brain of a human being. And this is what makes people quite scared about things, is to say what exactly is possible when you actually have that kind of capability. And of course that is going to evolve faster than human beings. So what type of thing are we creating? This is a broader question, but I think it's very important to realize. Sorry, you got to mute yourself, whoever that is.
Mm-hmm.
Hello, can you mute yourself, please? Yeah.
I'm not ignorant.
Sorry, you have to mute yourself. How do I mute all? 1 minute. Okay, cool. Okay, thank you for that. So I think that is good. Yeah. Let me see if I can mute all. For some reason, I get already about 60 people on this one. So I think all muted. This is good. So this is good. I'm going back to the presentation now. Yeah. So coming back to what I was trying to say here is that so what we're talking about here is the capability of building something which is quite complex, and also the idea that we are effectively sort of building algorithms which can do more things. Yes, so you can predict the data, what has happened. You can actually make prescriptive analysis. You can say what to do, and so on and so forth. So these are the areas which go along with there. And also, there's a lot of hype with AI, as you possibly know. And then this is a good example of sort of how people can say AI means different things. And then again, this is another example of hype within that. But again, my point here is that we just stick to what is important. And this is an important thing. So if you look at the way people really use AI usefully, and it's actually used as a competitive advantage. So if you look at typically the work I do in Germany, for example, or even my own company, the main point is that you use AI for essentially intellectual property. That's the name of the game with AI. And this is a samurai warrior called Miyamoto Musashi. And that's the point about him, that he's an intellectual, but also quite strong about sportsmanship. So the point here is that intellectual property is what AI is all about, certainly in my mind with that. Again, coming back to our definitions, because we are going to go much deeper into this sort of thing from now. And what type of problems when you use these things? When do you use machine learning and deep learning? So the question is that this is not an easy thing to do because you need to do this under very specific circumstances. Yes. So what we're talking about is if you use machine learning and deep learning for very large problems, the problem is open-ended, the problem changes, the problem is hard, the problem has hidden rules, and I'll come back to this. Problem has hierarchical rules, the problem has more variance around a core, or the problem is generative. So these are the areas when you would try to use machine learning or deep learning. And why does that matter? And what almost all these cases, the problem is not an easy problem to solve. And what that means is that if you sort of look at the three extremes, you can say that the simplest extreme is you have a rule for everything, correct? If you think about the idea of temperature versus temperature conversion, yes, so you convert from Celsius to Fahrenheit, there's always a certain rule for this, and the answer is always the same. If you know the rule behind a particular problem, then you don't need any form of AI or machine learning or deep learning to try and understand what that rule is. And this is what makes a difference, because what you really need is the ability to solve problems where you do not have rules behind them, and we will explain what that means very soon. So traditional programming looks like this. When you have data and the rules and you get the outcomes. Yes, so traditional programming means that you have your data and the rules, which means that you are giving some sort of if then else logic, and then you get the outcomes for that, which means that you're coding something and you get an outcome. But in machine learning, you give the data and the outcomes, and from that you get the rules. And this is the key difference between that. And I'm say machine learning, I also include deep learning into that. And the idea here is that you give the data and the outcomes, you find the rules. This whole problem is basically a kind of a flipped way of solving the traditional coding problem, is that you are trying to find the hidden rules behind a particular phenomena. Yes, and this is what makes it very complicated. And it's also what makes it different from traditional coding, because in traditional coding, you are very clearly specifying what those rules are, and you expect an outcome. But in, excuse me, but in this case, you are doing something different. You provide the data and the outcomes, and you get a set of rules within that. Now, the flow of this looks sort of a little bit more deeper into what we talked about before. You obtain the data, you clean the data, you explore the data. When you say explore the data, at that point you have no hypotheses behind it. So you have a certain idea about what the data looks like, but you don't know what it is really. And then you have the model, which means you do the machine learning, and then you interpret the results. So this is the general flow of what I talked to you before, but generally I'm sort of taking it a little bit deeper into that as well. And this generally flows into this way. So you start this idea of the same logic we talked about last time, and that goes from there as well. A little bit more detailed idea here, going slightly deeper into these ideas, and I go into deeper slowly because in the end for you everything will become core. Yes, and that is what it will come down to. So you have labeled observations, you have training data, and you have a test data. And on that, you have a machine learner on which you are learning something. And when you see a prediction model, which means you trained the algorithm on the data, and you see something unseen and you solve the problem. Yes, so this is generally how you would start to sort of work with that. In statistical terms, there are many techniques which come into machine learning or deep learning, and they include everything from linear algebra to sort of statistics and so on and so forth. Many of them are extremely useful to know, but you don't need them certainly to start off with. It's better to start off with looking at a problem, looking at the data, and looking at the code and trying to solve that problem. Yes, so it rather than get too worried about what is the maths behind it, which is very important, no doubt, and this is very important as a part of something like Oxford. But learning initially, you don't need to get involved into any of these things. There's also a whole bunch of computer science things. So there is things like as columnar databases, Hadoop, MapReduce, the whole big data thing, complex event processing, etc., etc. Again, not something which you need to worry about too much if you just stick to what we are doing now, which means sticking to the algorithmic part of it straight away in Python without as much sort of headache with the surrounding things from there. And then, of course, there are data formats. So there are a variety of data formats which apply, and that the algorithms depend on that. For example, time series has a whole different set of algorithms in that, which text has different algorithms, video has different algorithms, image has different things, and so on and so forth. But again, broadly, the picture should be quite easy for you. And then there are modalities. I already touched on this before. You talk about the cloud, the edge, and DevOps, and CI/CD, and all these things. Again, it's sort of tangential to the coding. This is why I said that it's almost important to start to know what you will not learn. Correct. So what you will not learn is all these things, because otherwise it gets extremely confusing and muddled into learning something with that. So what you will learn is a series of machine learning and deep learning algorithms, which we will list, which you already listed before, but we will list to you by next week. But they involve the core sort of areas which almost 90% of the people would be working with within that. And somebody asked reinforcement learning. We do a lot of work in reinforcement learning, but unless you are Google, it's not very relevant, because reinforcement learning is a very specific type of algorithm with a very specific type of problem, when it is not what you would traditionally use within that. So that's what I'm trying to say, that you structure what you're not going to learn, so that then you can focus on what you will learn within that. Now we come to machine learning. Yes, so machine learning, from our definition, again, I keep repeating these things because they're quite important, that we explicitly training an algorithm. Yes, so this is what we're trying to do. And it had a formal definition. The definition is that a computer program is said to learn from experience E with respect to some class T and a performance measure P, with the performance measured in task T improves with experience E. While this sounds like a little bit of a mouthful, the most important thing is that the first thing is that it is an algorithm which learns from data. So an algorithm which doesn't learn from data is not a machine learning algorithm. So for example, if you have something which does audio processing, for example, yes, so this is not learning from data. That's an algorithm which is not a data-driven algorithm, and therefore it is not a part of machine learning. And the word experience in this case is mostly associated with data. And the last part of it is improving with performance, because every time you work with something, it improves the experience of that. And the best example of that is something like Google Maps. Yes? So if you think about Google Maps, every time you use Google Maps, it gets better because it knows more about you, it knows from other people, etc., etc. So that's really how it works. So from a programmer's point of view, which is what you will end up doing, you train a model, you predict it, and you make a performance measure. So these are the three things you're going to try and attempt to do. Yes. And what are the types of problems you have? You have classification, regression, clustering, rule extraction, and so on. So it's kind of easier to see them visually. So classification is what you will try to do even as early as hopefully 2 or 3 weeks from now. So that is that you kind of separate a group into categories of things. Regression is when you're trying to find a line which best fits a problem. And in this case, you can try to see that the regression line is a line which is sort of covering as many of the round white dots as much as it can. Attribute importance is trying to find out things which are more valuable or are more numerous in number. Anomaly detection is trying to find out things which are outliers, meaning that they are not a part of a particular thing. For example, you are doing things like fraud detection and so on. Clustering is when you're trying to form things into groups. This is when you use things to separate things into groups. And then you have things like that. So those are sort of key algorithms in machine learning. There are a few others, and then this is only machine learning. It's not deep learning. We haven't gone into deep learning yet, but let me just sort of stop here for a minute and see whether people have any thoughts on this so far. Very good. So we are 15 minutes from a break, and that is good. Let me see the chat here again, what we see here. Okay. So yes, so the question the question here. Okay, there are a couple of questions here. Okay, let me just scroll up to see I get all the questions here. Okay, so that you can see the resources. This is good. Okay, so the question from Philip. How do I pronounce your name? Philippine, isn't it?
Yeah, perfect.
Perfect. Good. Yeah. What type of data are most fitting for machine learning or deep learning? What type of data is most fitting for? Typically, for machine learning, people use data which is which is structured. Yes. So, for example, if you are trying to do, and we'll do this as early as maybe next week or week after, certainly. Yes. So if you think about house prices, yes, excuse me. So if you think about house prices, a house price can depend on the number of features, correct? So it can say that you've got number of bedrooms, it is number of near a good school, etc., etc. It's pretty much tabular data. Yes, you have a column. A column represents a feature. For example, the number of bedrooms in the house is a feature. Yeah, and then the outcome is the price of the house. Yes. So for example, you might say that if it's a 3-bedroom house near a good school and near a good affluent area, then the price is so and so. Yes. So the type of data is tabular. In the case of deep learning algorithms, typically the type of data is image data. Yes, or something like that. So it's unstructured. It's pictures of cats, pictures of dogs, pictures of tumors, pictures of X-rays, that type of stuff. So this depends on the nature of the problem, but this is a gross generalization. Of course, you can use some algorithms in some cases, etc. as well, but generally that is the case. Is that okay?
Thank you very much.
Thanks. Yeah. So next question of Farid is, what happens when you have contradictory rules? Okay. So the thing about rules is that you're trying to find out rules which are which most apply to the problem, and in the case of rules, what you do is you find. So this is an important question, but I'll answer it in a slightly different way. So when we find out rules, these are probabilistic rules. So these are not deterministic algorithms. Yes, a deterministic algorithm is when you always have one answer for the same question. Yes, if you convert from Celsius to Fahrenheit, you always have one number. Whereas in this case, these algorithms are probabilistic, or what is called stochastic. That word means that you are saying that this is a rule with a probability. So if you think that if you find out 10 rules and the first rule is 90% true, then that is what the rule is, what you think you will accept, but that doesn't mean that the rule is applicable 100% of the time. So this is what I mean by these algorithms. Because they are data driven, they are what are called stochastic algorithms, not deterministic algorithms. A deterministic algorithm will always have the same answer at every time. And this is why this famous story of sort of using statistics to sort of present something also applies to data science, because many times the output of the algorithm depends on the data, the type of data, how fresh the data is, and so on. I hope that answers your question for it with that. Cool.
Thank you.
No, thanks. Yeah. So Abhinav, clustering and classification, what is the difference? Okay, that's a good question. We'll come back to them because we'll hopefully do them in code. Clustering is grouping things. Classification is categorizing things. Yes, clustering means that if you have groups of apples, oranges, and pears, you separate them into groups of apples, oranges, and pears. Classification means you're saying that you have cancer or not cancer. That's the thing. Yeah, I hope that answers your question, Abhinav. Yeah. So regression on all data. Okay, what is the question with that, Priyanjan?
So my question was, so normally when we are looking at the data from the machinery, so we have the phases of the production. So the product is going from one phase to another,
Yeah.
and then depending on that, we get to know how the product is being made, and then we know, hey, something is going wrong, and then
Yeah.
when something is going wrong, there is a regression line, like how wrong, like how did one, and we can also compare one factory with another factory for the comparison purpose. So, and these all rule sets we have to define, like we in the sense programmers.
No, the data defines it. The data defines it. Your training data defines it. You don't define the rules. This is the key point here with that. You don't define, so it depends on what you trained it with. So for example, you had, again I come back to the Boston housing, the same example I gave to Philippine, was that if you have a data set which has got house prices of over Boston, then you can predict house prices of Boston, correct? So that's the point about it. And so the rules depend on what you trained your data with. Does that make sense? Yeah.
Yes. Yes.
Yeah.
Yep. Yeah.
Okay.
Yep.
Thanks. Sorry, can you just me a minute? Yes, give me a minute. Yeah. Sorry about that. Okay, so I hope that answers your question with that. So the next question is from Ashwini, and I think that's the same question we just asked before, so that's good. What is the difference between test data and training? The training data is the data which is used to train the algorithm. Test data is the one which is used to see or validate the algorithm. We'll come back to that again with that. So about machine learning for Google Map example, is the feedback from users that is used to solve how will be used for machine learning correct? Yes. So to a large extent, when you train the data, you get labeled data, and the labeled data is what you use to train it. But as you run the data, run the algorithm, it is also learning through the feedback from the users. That's what I mean. So Shreya's question, does video category detection also come in deep learning? Yes. Video is a part of deep learning. Typically, that is how you would do it. You couldn't apply typical machine learning algorithms to video with that. So Valushan's question is replying to Priyanka. Yeah, okay, that's fine. Thank you for that. Thank you for replying to that. So how to decide which approach given a problem statement ML deep learning? Yeah, that's a good question from Anup. There is no easy answer to that. Part of it comes from experience, and part of it comes from something which we will show you also, is that you start with the baseline and try to improve that baseline. So what you do is you try to apply one type of algorithm to it, and then you improve the baseline using other types of algorithms with that. So, or you take a combination of the algorithm. So typically there is no exact way on what to use what, but typically if you're doing a classification, then there are certain algorithms which are used for classification. If you're doing regression, there are certain algorithms used for regression, etc. as well. So what we will end up doing by end of hopefully next week is actually show you which algorithms we are going to use for the problems we are going to face in the class. So this whole thing is structured around the 5 or 6 algorithms which we are going to run actually in code. So that's the situation with that. Okay, any more questions on this so far?
Thank you.
Yes. Okay, good. So what we might do now is we are almost close to the break. So we might take a break now. We'll take a 5-minute break. Actually, we'll take a 10-minute break. It's fine. So it's not a problem. I just don't want to rush people. We'll take a 10-minute break and we're back after 10 minutes. And then we'll start with that. So I will not specifically, I'll just come back after 10 minutes broadly and I'll start with that. And then everything is being recorded anyway. Okay. So we take a 10-minute break now and be back in 10 minutes with that. Thanks. Hey, Kauthar, welcome. Hi. Can you hear us? You there? I think you have joined, but I can't hear you. Maybe you're muted. Yeah, Prashant, yes, please. You have a question?
Yeah, hello, sir. Ajit.
Yeah.
So actually, I just on this one type same is my question. So just about the more for Google Map example. So you said that that is evolving or the machine learning, but it is not the same thing that depending on the feedback of the user, they are changing their algorithms. Miss how it is not the miss. I just want to know how it will be a machine learning.
Okay, I'll discuss that when we come back. Yeah. Okay. All right.
Okay,
Because I
okay,
think
sure,
we have a break now,
sure,
so
sure.
I'll just come back with that. So Kauthar, are you here? Can you hear me?
Yeah.
I think you're muted.
Hello, everyone.
Hi, how are you? Good to see you. Good to hear
Hi,
you. Yes.
I'm good. What about you?
Good, good. I'm fine as well. So sorry, we are literally on the break
Yeah,
now for about 10 minutes.
I'm sorry for late connection.
Oh, no, it's okay. It's okay.
Had,
No worries.
yeah.
So we mentioned you in the morning and said welcome to you as well. And Aisha is here as well. So Aisha obviously works with me on a number of areas and things like this. So cool. So we are on the
Yeah.
break for about 10 minutes anyway. But yeah, welcome
Yeah.
you're part of
Yeah. Okay. Thank
Okay.
you.
All right. See you soon.
Hi, Carter. Nice to meet you.
Thank you. How are you?
Right.
I'm good. How are you doing?
You got a special name, I see. Where are you from?
I'm from Turkey.
Okay, Aisha. Is that how it's pronounced?
Yes, yes, that's right.
Nice to meet you.
Yeah, and Aisha is part of my Oxford course and also my company. So we're always involved in things and also part of things, all the cool things we're doing with Facebook. So we're meeting on this metaverse stuff and so on and so forth. So just kindly offer to help and thank you for your code. With that, so we went through all your code and again, so yeah, trying to use all of that. Cool. Okay, so we see you.
Yeah,
We see
thank you.
you in
I'm
5
here
minutes.
if anyone have any questions or anything I can, interfere. I'm here.
Yeah, but at the moment, I don't think this is still on an early stage. And I also told them that so what we're going to do is we're going to present a little bit of the pandas and numpy and so on. So that those notebooks we got from Oxford really. So I think those are pretty much fine. But most of the code which you have been working with, Kathar, will be presenting next week onwards. So I think today will be more or less just explaining the concepts with that. So it's pretty cool. Anyway, but you're always free to be there. Yes. Okay. Cool. I'll be back in about 5 minutes. Perfect. Yeah.
Yeah, of course. I'm available if any questions, and of course for next week too.
Cool. Thanks. Yeah. So I'm going to start in a couple of minutes. Yeah. Okay, welcome back. So I guess I kept it sort of free in terms of also welcome to Kautar, who is also part of our team. So I mentioned Aisha and Kautar Marina. So Kautar is based in France and Morocco, so French speaking in that sense as well. Cool. So now I'm going to go back to this. The people were asking about training with Google, and one time as much data it had, but when you actually run something like Google Maps, Google is also reading data and is able to retrain the algorithm to make it better. So the whole point here is machine learning and DevOps, that you have to retrain.
Ajit, you're breaking in between.
In the field, and or when you decide
Ajit, your voice is breaking.
Should be okay. Not sure why it was breaking, but
Yes, much better. Oh.
okay, good, thank you. Okay, good, perfect. So I'll just start presenting again. To sort of explore a little, until it doesn't matter because we can continue on from there. But at 5 o'clock, I shall take over. And at that point, we will start working with code. So we will show you how to work with code, and we'll give you about 15-20 minutes when you can experiment and come back. And then Aisha will tell you a little bit more about if you have any questions for that. The point here is that we will kind of break this into a series of ways in which we learn the concepts as well as we learn the code. It doesn't matter if I don't complete all my slides today because there is a lot more which I haven't shared with you. But the point is that at 5 o'clock, which is about 55 minutes from now, Aisha will start to present about the code, and then we'll give you another 20 minutes or 30 minutes to go and explore the code, and then come back and ask some questions, and that will take us up to 6 o'clock within that. So now I'll proceed for the next 55 minutes to again explore a little bit more about machine learning and hopefully about deep learning as well. So when we say something is learning in machine learning, yes, so if you think about the classic kind of this equation of a straight line which you kind of learned in the university. So in this case, this particular equation is a very straightforward equation because it's a straight line. The equation is y equals to mx plus c, if you remember it. In this case, c equals to 0, therefore y equals to mx, yes. But if you think about an equation like this, on the right hand side, so you have function x, we have a function of x and x on the x-axis, and the function of x is quite complex because this is no discernible pattern to this function. Yes, so what you're on the left hand side, which is the equation of a straight line. what you're trying to do is reduce the software errors for each brains and try to find best fitting line. This is achieved using traditional math techniques such as statistical techniques. The equation on the right hand side has no discernible way in which you can kind of plot or connect a mathematical function to that. However, given enough data, given enough examples of the data, you can actually map your x-axis to your fx, which is your y-axis, and this is the power of deep learning. So what you're trying to do here is that if you train it using enough examples of this, it is able to understand the hidden pattern behind those examples, and that is how it's able to determine what the function x is through that. And the way you do that obviously is through a neural network, and that is the sort of capability and the power of deep learning, but also comes at a price because it is more expensive, more complicated, and so on. So this is really what is driving AI, but to a large extent it is similar to what you already had before, because you already had the classic sort of machine learning algorithm which tried to fit in a straight line between a set of points. But on the right hand side, if you do not have a discernible pattern which fits the fits the x and y axis, then you can use data to understand what is the hidden pattern behind that. So the word function here is the same as what you used in historically in mathematics. Yes, you given a domain x and given a domain y, you try to find out a fx which maps your x to y. Yeah, and this is the same problem also in machine learning or deep learning, that you're trying to find a function which maps your inputs and your outputs. Yes, and those functions may be complex, they may have certain other rules, they may have hierarchical rules, but the problem is still the same. The problem is that given x and y as two domains, you can map domain x and domain y to try to find out some hidden function within that. And that's generally what is defined here in the terms of the sort of a function, and this also it could be treated as a black box. Now a black box function is something which people get very kind of unsure about, partly because they don't know what is inside it, and that is the deep learning is typically a black box algorithm, so it is unable to exactly explain how the mechanism worked behind it. And that is not a malicious thing. It is mostly because you have the deep learning algorithm is a neural network with a series of weights and biases, which are very hard to explain to a third party. However, there are other ways to, and this is what you do. But what you are able to see is that you're given an input, you're given an output, you know that there is a function which is transforming your inputs and your outputs, and if you give enough examples of the behavior of the function, you should be able to map that. And that is the point of something like this, is to say that you can find out a hidden function given enough examples of the problem. Yeah, and this is how sort of mathematical modeling fits in. If it's a model, you create a mathematical model, and you get conclusion into machine learning model by trying to simulate the behavior of that, find out what the hidden function behind it by using data within that. So now we come to different types of algorithms. Yes, and this is where you're going to start to explore at a very, very high level view what those algorithms are, because you need to understand what those algorithms are, because otherwise you will sort of not know what to do with them. There are two broad ways to classify algorithms. The first one is by learning style, and the second one is by types or categories. So if you look at learning style, the first one is supervised learning, and the vast majority of algorithms are supervised learning algorithms. Supervised learning algorithm, which means you train something based on data. Yes, so you train something based on examples or learning things or labeled data, correct? So you have data, you have a vast majority of the problems, including things such as self-driving cars today, are based on labeled data, because you need some examples, you need it to label something within that, and it's able to show or what that label is. Second one is unsupervised learning. So unsupervised learning is what I showed to you was clustering, when you're trying to find things which are similar to each other. An algorithm which does unsupervised learning is called k-means, and that's what that's how you do that. Then you have things like anomaly detection, which are sort of areas in areas like fraud and so on, which are many unsupervised learning algorithms are used for that. Then you have something called semi-supervised learning. So semi-supervised learning is when you give some examples and then from
Yeah, Ajit, it's breaking again.
and there are many generic out a little bit later.
Hi, Professor.
No, it's breaking for me also.
Yeah, it's for all of us.
Okay, I don't know what to do then with that,
But
because
now it's little better, Ajit. We can hear
when
you.
you say breaking, what?
It's
Okay, I think I
chopping.
had lost my internet connection basically. Yeah, it's back now. Is it back now?
Yep, much better.
Yeah. It's a connection issue. Yeah, you're right. I think yeah. So it was a connection issue. I was it was yeah, it had lost the connects, which is a problem. Unfortunately, I can't do anything about it. So I think we are back now. Yes, you can hear me now. Yeah. Yes.
Yeah, we can hear you.
Okay, good. Okay, good. So I'll go back to the presentation with that again. Yeah. So talking about algorithm similarity. Yeah. So what we're talking about here is things which are similar to each other. So for example, we have regression algorithms. So regression algorithms are mostly based on the idea of trying to find a pattern or a line which fits most of the points. And this is what you do. So you typically find the ordinary least square regression. Again, we'll be doing that hopefully from next week onwards or week after next onwards. Then you have, this is how it works. That's the regression. Then you have classification. That is something also we'll be doing next week onwards or the week after. This is the cancer detection problem. And there are a number of algorithms like SVM, logistic regression, etc. And what you're trying to do there is trying to classify it into two categories and trying to find a new data point, whether it fits into one or the other category within that. Then there are instance-based algorithms, which have K nearest algorithm, which is a way of sort of trying to see things which are near to each other. Then you have regularization algorithms, which penalize models based on their complexity. Again, we will be looking at this later on, but at this point, I'm just sort of explaining what those things are for you. Then you have decision-based algorithms or tree-based structure algorithms, which are used for classification typically. And this is just a decision tree, which tries to say which category things fit in mostly within there. Then you have Bayesian algorithms, which depend on the Bayes theorem, and they are used for classification or regression. And then you have clustering algorithms, which we already talked about. So this is an example of clustering, trying to find out things which are close to each other. Then you have K-means is an example of a clustering algorithm. Then you have association rules, which means that you're just trying to find out similar things which are similar to each other. So for example, if you have retail application, and it's trying to say that if things are bought together, if you buy, for example, burgers and ketchup together, then this is an association rule. You can again depend on the data to find that rule, which is also called market basket analysis and things like that. And then you have dimensionality reduction algorithm, which you'll be definitely doing in the form of PCA, which is towards the later part of the course. Again, it's hard to explain what dimensionality reduction is at this point, but I guess you will come to know more as you go along. But at this point, we're just trying to sort of take a bird's eye view of the world and trying to see what these algorithms are. And then we are going to narrow it down to a series of algorithms which we'll be working on with that. And then there are ensemble algorithms. The word ensemble is a French word which means you combine things together, and typically you use algorithms so that you combine the outputs of many smaller algorithms to create a bigger output. And this is the philosophy which is used in quite a few of these algorithms within that, and so on with that. Okay, cool. Any questions on this?
Hi, Ajit, Santosh here.
Let's see
Question. Yeah, hi. Can you hear me?
Yeah, 1 minute.
Hi.
Yeah,
Yeah,
sorry.
Ajit.
Yeah, 1
Hi.
minute. Here. Yeah, go on.
Yeah. See, so far we always learn like, using an equation get the outcome. Yeah. But the way you described in this session is, you are actually finding out that function of x. What is that function of x? Knowing x and y values, what is the function of x? So do we have to undo what we have learned maybe in our life earlier so far?
No, not really. I mean, there are different you should do it because it's the quickest way to do it without much data. Yes. However, there are many examples where you cannot find an exact function just purely by sort of putting it in an equation. In that case, that's when you use machine learning or deep learning algorithms. Okay. Cool. Thanks. Yeah. So I will come back.
One more thing. I mean,
yeah.
I felt like, are we going too fast? Because literally few seconds per side, there are quite a few new terminologies here, or
Yeah, that's
you're going
fine.
to cover that afterwards.
Yeah, well, this is at the moment just a top level view. So we'll come back to more details as well later on.
Okay, thank you.
Cool.
Thank you.
Okay, so this is regarding the voice without voice breaking. Okay, so now I can see, because I don't see the chat. This is the problem. When I'm presenting, I don't see the chat at all. So now I can see the chat. People have the voice problem. Hopefully it's all fixed. Yeah, so I don't know why, but I think the connection was lost and it's back now. So the question is, is classification always now for also how we come to a decision? So is it okay? Let me try. Okay, let me try. Can you hear me now again?
Yeah, we can hear now. It's okay.
Yes, yes, we can hear you.
Yeah, okay, you can hear me now, I think, yes. I think the
Yes.
problem is with us. Yeah, I think the problem is with software updates. Unfortunately, it's not a network connection. It is slowing down the network connection so slowly that I think this is a Windows update or whatever it is, and there is nothing I can do about it. Unfortunately, while it is working somewhat, but because when I see this presentation, I can't see what people are saying anyway. Okay, so I think I've answered all the questions. Correct? Yes. Any more questions on this so far?
Yes, sir. So this is Shreya, and I wanted to ask you that see number of algorithms you have told, and at the last there was some term that you have told that you have to use a number of algorithms for particular data set. So how come you come to a conclusion that I have to go for number of algorithms? Is there any way, or is like for tuning the accuracy we are just keep on trying the things?
Yeah, it's a mixture of both. So what that means is that we are trying to find out a baseline accuracy and then trying to improve the accuracy based on whatever we think we can do. Yes. So that is an end goal. You're never going to get 100% accuracy, but you're going to try and do as many things as you can to improve that accuracy so that you can improve that. So the short answer is that the typical way you really work is you find a baseline algorithm, then you continue to improve that algorithm using a number of ways in which you can improve that. And there are a number of ways in which you can do it. One of them is combining different algorithms. I hope that answers your question for that. Cool. Okay, good.
Okay.
So let me go back, assuming there are any more questions on this so far. So we got another 30 minutes before I hand over to Aisha. Like I said, we won't be able to finish everything today, but that's not a problem. I just want to go back here and see how much we have in which we can do. Okay, good. Yeah, because the deep learning stuff with that. Yeah, that will definitely take time. So what I want to do now is we had a quick look at some of these algorithms, and of course we won't be doing every one of these algorithms. We'll be doing some of them in more detail. So what we're going to try and do is sort of um, look at some basic terminology with machine learning and deep learning. Yes, so we start with the idea of machine learning, and we have the idea that we put things in a matrix format. So things would look like this, for example. So you have the position, the developer, the skill, the country, the city, and the salary. Yeah, so this is these are number of features being help you to determine what the target is, and the label shows you what the value is. In this case, is a salary of whatever. Yeah. Similarly, these are house price examples where you show what the house prices are, and then you show, or the target attribute is med-v, which is the median value of a house price within that. So the idea here is that you train something and you make sure that you learn from it so that it can learn that. So in this case, the idea here is that we are learning the Boston house data set, and from there we are trying to understand what the features are. From the features you're trying to understand, predict the median value. Here you're trying to predict the salary based on the sort of features which give you the salary. In both cases, it's a regression algorithm because you're trying to predict a particular number at a point in time. Yes, so this is what we do, and of course we are going to do this in code very soon within that. To train a machine learning algorithm, you need to learn with the data. You also need to learn on certain hyperparameters, which are certain tuning parameters which are set up to train that algorithm. And again, you do something similar to what I said before, and this is what you will end up doing in the code, that you will learn from the data, will make a prediction, and you will make a prediction on that. So this is the idea with that. And the general idea is, if you expand that a little bit more, and I'm kind of expanding this pipeline very slowly, is that you have your training data, your test data, you have a learning algorithm, and it has certain things like just model selection, cross-validation, hyperparameter tuning, and so on. And those we will come back to as we go along. So at this point, I'm sort of expanding a little bit more towards what the sort of algorithm is going to look like within that. Now we come to something called deep learning algorithms. So far we talked about machine learning, and then I said to you that we're going to talk about deep learning. So in the next whatever about 30 minutes, I'm going to start talking to you about deep learning algorithms, because what we are going to do is we are going to work with some machine learning and deep learning algorithms. Yes, so this is what you mean by learning to code with artificial intelligence. You need to learn both machine learning and deep learning, and this is what we're going to talk about, the theory or the concepts behind deep learning algorithms. So first of all, when we look at the idea of artificial neural networks, yes, so the idea of a neural network is that of the sort of the brain, and what you're trying to do is trying to model the behavior of the brain using neurons. So the idea of neuron in a neural network is the same as what you see in a deep learning network. And why that matters is because in a neural network, they are arranged in a particular sequence. And of course, if you see the picture of a brain, it doesn't look like that. Yes, but the reason why you arrange the neurons in this sequence is because they're computationally feasible, meaning that you can kind of understand how those neurons connect with each other, and you can actually build that into a mathematical model from which you can derive something from there. But the end goal is the same. So this is the neural network here you have seen here. And the difference between the one on the left hand side here and the one in the middle here is that the one here is trained. Yes, the one which has got more green connections is trained. When you start with a neural network, it does not have strong connections. You then use the training data on which you get those connections, and then you use inference, meaning that you show it for the first time and you get an example of what it does. Yes, so this is the sort of end game when it comes to neural network. But in both cases, it's a classification. So you're going to see classification in the cancer example, where you're going to classify something has cancer or not. And in the case of this example, you're going to see whether it's a cat or not. Correct. So in both cases, it's a classification, but it's obviously a different type of data, because in the first case, you have straightforward a tabular data, but in this case you have a much more deeper, richer data within that. And then there are more examples of deep learning, which are different types of deep learning within that, and they include autoencoders, variational autoencoders, GANs, reinforcement learning, and things like that. But they all have one thing in common, and they are based on the idea of a deep neural, which has got many layers inside it. So this is the main. I'll explain to you why that seems to be an important part within that. So now let us think about what are the problem we are trying to solve in deep learning. Yes, so it's all about finding rules, and I explained to you that that's what we are trying to do. Yeah. So if you think about rules, then rules are what you try to do, even if you are effectively trying to find something. Yes, so the best way to it's about training. Yes, so there are certain rules which you can do very easily and you can train, and certain rules which you cannot. So the rules which you cannot find very easily are based on things which are not easy to understand using traditional means. So for example, if you have a simple if then else rule, then that rule is quite easy to understand. But if you have a top-down rule, is very easy to understand. So for example, you can say that if you can understand a particular problem and find out all the rules which define the problem, then that's very easy. But there are many cases where you do not know what the rules are for a problem. And in this case, you need to find the rules bottom up, meaning that you need to find the rules from the data. And those rules are non-deterministic, The problem domain typically is not finite. So the word not finite problem domain is something like this. Yes. If I look at the problem of chess, the problem of chess is a finite domain problem. A finite domain problem means that you have 8 by 8 squares and you have 64 squares. And in that case, each portion, each thing in the chess moved in a very specific way. But the problem on the right hand side is an infinite domain problem, but it's easy for a child to understand. So for example, the problem on the right hand side is trying to find out, the child trying to find out whether this is a dog or not. And a child can do that based on the features of what makes up a dog. Yes. But in the case of chess problem, it was easy to find those features because the problem domain is finite, and that's because you have only 8 by 8 squares. But on the right hand side, the domain is practically infinite because there are many varieties of dogs. There are many variations of a dog. For example, you have a dog with a long tail or a short tail or long ears or something like that. So it is not possible to find out how exactly you comprise the concept of a dog. However, a child can understand what is the concept of a dog based on the understanding of the features of what makes up a dog. And this is where I think the significance of deep learning comes through. And that is what I mean by the rules which make up what is a dog are complex and hierarchical compared to what is there with chess, for example, which is the relatively straightforward problem which was solved by computers some time ago. But deep learning as a structure is available now into many areas, which include CD, Facebook, and things like this. And most people heard about deep learning for the first time when we looked about this Andrew Ng's experiment of trying to find out cats from YouTube videos. So generally, the sort of examples of deep learning are when you have an infinite domain problem, and when you're trying to learn the nature of the problem from the data itself. Yeah. So when you have something like this, the problem works bottom up. Yeah. So if you look at a picture like this, what you are seeing here is that the lowest layer of the neural network finds out pixels. The one above finds out the edges. The one above finds out the contours. So each layer picks up something and learns something and passes it on to the next layer, and so on and so forth, until the last layer is able to find out what the features are which make up this person. Yes. So for example, at the second to the last layer, it would say that this this is a headset. The person has got glasses and something like this, and from that it is able to see what type of object this is. Yeah. So, but of course, to do that, you still have to train this algorithm using lots of examples of data. But the fundamental way it works bottom up. And this is the main difference between deep learning algorithms and other things, because deep learning algorithms are able to learn through a very deep neural network. And each of those neural networks are learning something and passing it on to subsequent layers in the neural network. And that's why you see diagrams like these, where it is able to find out some things and build up images from some things until at the higher levels of the network, it is actually able to understand what that network is. Yeah. So I'll take some questions now. First of all, I want to be sure that people are still able to hear me, which I think they are. Yeah, good. So good. Yes, you can hear me better now. Yes, I think, because the thing is, when I come here, I can see my microphone moving, and then I know you can hear me. Okay. So any questions on this so far on the deep learning stuff? Yes. So thank you, Kautar, for posting that. That's good. Any questions on what is deep learning so far?
One question.
No?
So you
Yeah.
have you have illustrated one example related to that identifying that image, right? So for each neural network hidden layer, you have just specified some of the things like finding out the pixel or finding out the contours. Okay, so do we understand how it works, or it's like a black box only, right? We are just training the model, but is it possible that how it is getting identified, the things are getting identified by the system? Is it any way to understand that?
That's a very good question. And the short answer is, and first thing is, when you said that, do you specify how it works? So the thing is, we don't specify how it works. Yes. So what we are saying is that it does it on its own. And of course, it does it by lots and lots of examples when it is trained and retrained and tries to identify a pattern which is underneath that. But when it is fully trained and it is able to identify something, then it is able to effectively build up those relationships from bottom up. Therefore, the first point is that we don't explicitly say what to do, but what it does do is it's build it up bottom up. So therefore, when you have an image, the lowest layer builds up pixels and so on and so forth. This is the first point. The second point is it is indeed a black box, and this is one of the biggest problems of deep learning neural networks. And the problem is that it is hard to explain to somebody how you arrive at a conclusion. And the reason you arrive at that conclusion is because when you fully train the neural network, you have a series of weights and biases, which I will explain to you in the structure of the neural network, but those are very hard to explain to somebody. So for example, if this were a neural network which was training somebody, training to detect whether you had cancer or not, or even when you had pictures of something, it isn't able to say how exactly it was arriving at that conclusion, because all it has is a series of weights and biases, which are the inputs and outputs of the neural network. This is one of the biggest disadvantages of neural network, but there are some ways to overcome that. But I hope that answers your question, Shreya Desai. Yes, you asked that question. Yeah.
Yes,
Okay.
and is
Good.
it like for
Thanks.
yeah. Is it like that whenever I get a set of I have a set of data, do I need to specify it like that this is a training data or this is a testing data, or it's segregate by its own?
So that's something, again, you will do it in the code very soon. So when you have training, you have data, you take about 60%, for example, for training data, and you leave 20% for test data, something like that. So that's how you would that's how we would do that. So yes, Scout has posted something. Whenever I work on machine learning model, they start giving these results depending on how examples. Yeah, so I think that is an example. Thank you. I hope that answers your question, Shreya.
Yes.
So thank you also, Kautar, for posting that. What amount of data is needed? So this is something which is there. This example. So this is another. It's a complex question, Dr. Gore, with that. And like Kautar said, that there is a bare minimum examples you need to sort of work with that. But the more, so the thing is, the amount of data depends on the complexity of the relationships you're trying to find out. Yes. So the deeper the relationships and the more complex they are, the more data you need to do that. And this is a deep learning algorithm. So when you have lots of images or something like that, but when you are, quite often you don't have enough data. So for example, I worked in bioinformatics. So bioinformatics, you have sometimes, even Kautar works in healthcare, in areas like that, where you do not have a lot of data. So we were dealing with the condition. It's a kind of a trade-off between that, but as Kaushik said, there's a minimum thing people do, and then you sort of build up on top of that. So I hope that answers your question. I know people have raised their hands, so I'm also going to address them as well. I'll take some questions now with that. So Kaushik also, they had reasonable results. Okay, yeah, that's right, correct. So that's, again, thank you for that, Kaushik, again. So I'm going to take the next question from Purva. Yeah, but I have to speak up. Yeah, Purva, yeah.
Yes, sorry, I was on mute. So actually, I have one question. Like in the slide, there was a picture of a child with a dog. So in that, like we were trying to distinguish between a cat and a dog. So if we look at the feature wise, like both have the four legs, both have the tail. So the inner layers of the deep neural network like perform some kind of a clustering to distinguish between them, or what kind of a like algorithm is used to like distinguish that.
Yeah, so the exact algorithm we will come back to later on, but it is not clustering, I can tell you that. So the way the neural network works is pretty much as I showed you in the picture there, is that every layer at the bottom layer builds up on something, and then the layer above that builds upon something else. So for example, when you said that it has four legs and sort of ears and something like that, yes. So the lowest layer in that case would find out pixels from an image. Then the layer above will try to find out the shape of the legs and something like that. And the lower and the higher levels would try to find out if it has four legs or ears or whiskers or things like this. So those features are derived from bottom up. And that's why I use the definition of deep learning as automatic feature detection or representation learning. Yes, so this definition actually says that you learn the features automatically. So the main difference between machine learning and deep learning is that in machine learning, you explicitly define the features. So for example, you explicitly say for Boston housing data set or whichever data set you have, you say that the house prices are dependent on 3 bedrooms or 2 bedrooms or proximity near a school, etc. And this is what you provide based on your experience. But in a deep learning algorithm, it tries to find these features on its own. And that is why the definition of deep learning, which I used, was saying basically automatic feature detection. So that, I hope that answers your question. It's not a full answer to your question, but the main thing is that it is not clustering. It is basically use an algorithm called backpropagation and gradient descent. That's the long answer to your question, but
Actually, I lost you in the end.
we haven't now, so I won't go into that. Well, that's all I was going to say with that. I think that mostly it is basically based on the idea of what I said before. It's based on bottom-up learning with that.
Got
Okay.
it.
Yeah. So I have a question, and since we are like discussing only high level at this moment, when the term neural networks was coined, does it really have a relevance or connection to how the actual brain neuron works? And could you please shed some light on like what is the association between the two?
Sure, that's another very good question. So historically, that is what people aspire to do. Yes, so when people build a neural network, they aspired, and this was the 1950s. Yes, so the history of deep learning neural networks is quite old. And the earliest example is in Dartmouth University in 1957, I think. And they tried to build this idea of a neural network based on a brain. Yes, but what they found out was that it isn't possible to computationally build something which actually works when you have one neuron connected to many other neurons. So they made a simplification to put those neurons in layers, and this is why you see something which is called a neural network, but it's not like any brain you have seen, because in any brain which you have seen, you have all these neurons connected to all these other neurons, but that's not computationally implementable, because there is no point building something which is abstract or purely a conceptual thing, because what you want it to do is to work to solve a problem. And in that sense, it is inspired by the working of the brain, but it isn't directly connected to the working of the brain. However, it is moving in that direction, meaning that as you go into more and more of these more complex algorithms, many of them are trying to sort of work more closely by trying to understand features from how the brain works with that. Cool. Okay.
Thank you.
Hope that answers your question. Yeah, cool. Yeah. So John, I'm just sort of shifting back a little bit towards the chat as well. John, I wondered if you would be covering backpropagation and partial differential equations later on. I covered them in Oxford. I don't think we have enough time for this. I will share you some links on how you want to do that if you want to get involved into that. Actually, the person who is doing that with me at the moment is Kauthar. Kauthar and I are working on something at the moment. We can happy to share with you, John. You're connected with me anyway. But I think within these 8 weeks, I won't be able to get into the mass of this. Yeah, for sure, almost certainly, because I think that would lose a lot of people here if I got into the workings of backpropagation. But Kauthar and I can share with you things with that. Is that okay, John? Yeah. Cool. Let me just go up here. Let me just see if I've missed anybody's question on the chat. Okay, we covered. So Farid, are we saying machine learning is top-down and deep learning is bottom-up? I am generally saying the principle, machine learning involves you defining the features in advance, and in that sense, it is top-down. I am saying deep learning in general involves finding the features from the data bottom-up, and that is how I'm trying to say that these are not literally hard and fast rules, because you will be finding some exceptions one way or the other. But generally, the concept is that when you're doing deep learning, you're trying to learn both the features and the learning from the data within that. But in case when you're doing machine learning, you actually specify the structure of the data, and this is what I mean by that in that example within there. I hope that answers your question. So Robin, okay, yeah, so it's a debatable thing, but I think we've covered that a little bit with that, so that's all good. So Philippine, I think with machine learning, prefer categories in machine learning, seem to recognize the categories. Deep learning, you have to. So the bottom line is that it's the same thing what I said, that with deep learning you learn the structure of the data. And in machine learning, you are typically providing what the features are. Yes, so that is why I use the definition of deep learning as automatic feature detection. There is another word called representation learning, which also means the same thing. So in any case, the deep learning algorithm basically tries to learn both the structure of the data from the data itself. But in the machine learning algorithm, typically you specify the structure in advance. When I say the structure, I mean the features within that. Okay, I hope that answers the question from there. I'll just go down again. So machine learning, what is the algorithm in the form of libraries, like for classification? No, it is k-means in the case of deep learning. So that we will come back to that. There are a number of libraries and algorithms. We will come back to that. For deep learning, I've come across CNNs. Yes, we'll be doing CNNs with that, convolutional neural networks. TensorFlow is the library. Yes, we'll be using TensorFlow in the course. And as Kauthar has also said, that there are a number of different algorithms within doing that. Are any of the real life examples when deep learning and neural networks are used? Oh yeah, there are tons of real life examples when deep learning and neural networks are used. Everything from healthcare to self-driving cars, all of them within there. That's again good. So Kauthar been answering those questions. Does neural network use sample data or full data to define the rules? It depends on how you structured your problem, Shreya. So you can choose whichever ones you want within that. So it depends on how you used to train the data. For so Shaurya, for lower level, will the size also detect the cat or the dog? No, at the lower levels it doesn't detect the full thing. It just detects the lowest thing. So for example, the pixels and the boundaries of something and so on and so forth. And only at the higher levels it starts to detect the features, because the thing is, everything is building on top of each other. This is Shaurya Kelkar's question. So whatever you're doing at the lowest level, the layer above is building on the previous one. So this is the bottom line with that. Cool. I hope I've answered all the questions in the chat now. So Atul, yeah.
Yeah, hi. I'm bringing this question from a software quality assurance or testing perspective. In the current ways of working, we know the rules, we know, and then we build the software, and then we validate whether the software is built to behave or perform as per the rules, right? And in AI/ML now, we don't know the rules, but we know the outcome that we want to have it, and we try to get those rules built, right? Yeah. So from a politician's perspective, what are the ways has been used currently to ensure that whatever the rules has been built or predicted are good enough to use, and as time goes, it will be again better or made it much more better there.
Yeah, so there are two questions here, and both are good questions. The first question is, how do you know if something is accurate or the level of accuracy? And this is something which we are going to see soon. So there are various metrics to use accuracy or the regression metrics and so on and so forth. And those are very well defined, and those will come to know in the course. We'll come back to that very soon. With regard to your we make sure that it is there or it's still live. This is why you have to retrain that. You might get it running in production today, but your data might have changed. So after 10 days, it's no longer valid. So you may have to retrain it. So this is the point here. So those are two different things. And many times the second part is done through, if you have a testing background, then this is generally done through something like ML Ops. If you know tools like Jenkins and things like this, where you are able to sort of do that type of DevOps feature, and then you combine that with some ML features, and most of the platforms now are able to do some kind of ML Ops within that. I hope that answers your question.
Yeah, brilliant. Thank you very much.
Thank you. Yeah. So one more question here now. I think so Shreya, I just come back to your question, Shaurya, but pictures can be taken from different perspective. Exactly, that's right. So it is different perspective, but they all should be able to identify that it is a dog. That is what it is. That is what is the meaning of the word abstraction. Yes, the word abstraction, meaning that you find out what is the salient features of something. It doesn't matter if the dog has got a little bit of a, it is in the shade, or it is in the sun, or it is particular.
Yeah, hi sir.
Hey,
Just
Dr.
I was listening to this deep learning that we are providing the data for deep learning, and based on the data, it determines the features, and it follows the bottom up approach. But it entirely depends upon the quality of the data, right? So the data that we are providing is not has a quality data. For example, we are trying to figure it out the image of the cat, but we are not feeding the image of the cat. We are feeding some other animals images and data. So it will how it will determine then. So on how to assure that.
So it doesn't work. It doesn't work. It doesn't work if you don't provide it data, which is relevant.
So how to
So
assure
it
the
has
quality of
to.
the data, because it entirely depends upon the quality of the data.
So it will depend on the accuracy of the algorithm, meaning that once if you train it to detect cats and dogs, yes. So when you actually run it, if you show it 10 cats, yes, if you show it 10 pictures of it, 7 are cats and 3 are dogs, yes. If it is able to only detect 1 or 2 cats, then it is not successful, yes. So you didn't train it. So in the end, it all depends on how it works. This is my point, yes. So in many cases, that those things are all leading up to the thing, because the training bit is just a training bit, because when you actually infer it, that's the time when you test it. Correct? Make sense?
Okay. Yeah.
Cool.
Okay.
Okay, thanks. So what we'll do, because I think we have another five minutes more to.
So hi Ajit, can I ask one more thing? So the success depends on how. So the success depends on how many times you get the right result.
Something like that, yes. There are a number of metrics to do that. One of them is this one, yes. So the point I'm trying to make is that you can train it using whatever data, you can do different things and so on, but the end result is when you run it in the field. When I say in the field, which means it hasn't done it before, how do you know it is successful or not? Because you show it examples which it has not seen before, pictures it has not used for training, and then it is able to correctly determine the answer. And this is the acid test, so to speak, yes. And then if it isn't able to define that, you have to go back to your training and do something else with it.
Yeah.
Cool. Okay. So Aisha, are you there or not? maybe not still.
I'm here.
Yes, you are. Okay, good. Okay, very good. So now, Asha, what I'm going to do is I'm going to give them another 10-minute break. Yes, because I don't think you will take a very long time. So what I'm going to give them another 10-minute break, and then you take over, and then you explain the code and things, and then we'll give them another sort of 20 minutes to sort of work on the code, and then we'll have another 10 minutes to catch up. Is that okay?
Yes,
Cool.
sure. Yeah, just
So
I'm here.
We'll give you another 10 minutes. If you don't do the coding, then you wouldn't be able to sort of do much with it.
Sorry, Ajit, I couldn't understand you properly. You were again cutting off. Okay.
Break, and then you are.
Yes,
Yeah.
sure.
Okay, cool. Thanks. Yeah. Hi, Shay. So when you're ready, we can present another. Give it another 5 minutes. Is that okay? I think you're muted.
Yes, that is okay.
Yeah, sure. Give it another 5 minutes, and then you can take over, and then we'll just
Okay.
work with that. Yeah.
Okay.
Hello, sorry, I'm late.
No, that's fine. We're about to start now. So actually, we can start now. I think this is fine. Yeah.
Okay, so let me share my screen. Ajit, can we see all the screens right now?
I don't see your. Yeah, it's coming through. Yes, it's coming through. Yeah.
Is it coming?
Yes. Now we can see it. Yeah.
Okay. So let's start then. Hello, everybody. Welcome to the workshop. And just a quick intro about me. My name is Ayşe Mutlu. I'm the lead AI tutor in the Oxford course, and I'm responsible for the technical aspect of the course. I look after for the coding sprint and the development. I'm based in London. I do work also as a data scientist, and I'm mainly focused around the deploying machine learning and deep learning algorithms on the edge devices. So let me start the slides. So the today outline is let me just mute everyone here. I'm not sure if I did that. Okay. So today, what we're going to do is I will introduce you the Python and the Python libraries that are used in the machine learning. And these libraries are Numpy, Pandas, Matplotlib, Scikit-Learn. And in addition to the presentation, we have the notebook materials provided that are related to all the libraries we will cover today. So you can download them from Slack and for the first week. I will also explain how you will be working on those notebooks. So the Python is beginner-friendly computer programming language. People from different disciplines use Python for a variety of different tasks, such as data analysis, visualization, artificial intelligence, machine learning, or automation. So like I said, these are the main libraries: Numpy, Pandas, Matplotlib, Scikit-Learn, or TensorFlow. So within the workshop materials, the notebooks are designed to provide you the baseline. So many of you may be familiar with these libraries. I believe it will fresh your knowledge, and if you are new also, it will be a great start for you. Let's begin with a very generic library of Python, which is Numpy. It is one of the most useful libraries in Python, especially if you are dealing with the numbers, because it is faster than using the Python list or Python loops, and it has many built-in functions. The second library is Pandas. The Pandas is a Python library that gives you a set of tools to do the data science and data analysis. So with Pandas, what you can do is you can download, prepare, manipulate the model, and analyze the data. You can join the data, reshape the data, take the data from different databases and put together and analyze it. So you can do pretty much anything you want with data. The next library is Matplotlib. It is one of the Python libraries, and you can do visualization with your data like this. You can do bar graph, histogram, scatter plot, area plot, or pie plot. So you can even look at images and manipulate images too. There are also other libraries which does visualization, like Seaborn, which you can use for the Python data visualization. And the last library we will look into is the Scikit-Learn. And so it is one of the most used machine learning tools. It is a simple and efficient tool for data mining and data analysis. So what you could achieve using Scikit-Learn is you use it in regression and classification, or clustering, model selection, or pre-processing, or dimensionality reduction. So in here, so we are seeing the machine learning workflow here. This is the, so if you have a problem, and what you do is you try to understand the data. First of all, you start to explore the data. You understand the problem, you understand the data, you do feature selection, feature engineering, pre-processing. Then once you processed your data, you come and do algorithm selection, and you define your baseline algorithm. And then you train your baseline model, and you assess the performance. Then you start to improve your model and get the best score for your use. And here we talked about the libraries, and here we can see how these libraries fits into the machine learning workflow for the data analysis, or for the algorithm selection, model selection, or evaluation. So this was the brief introduction for the libraries and the machine learning workflow. And now we will jump into the code. And before that, I want to say that we are going to use the Google Colab. And Google Colab is a cloud machine provided from the Google. So it is hosted Jupyter Notebook service, and you don't need to set up anything, because it has all the free, including that it has the free access to computing resources like GPU. And to get started to use the Colab, you can have a look at these references, but I will also go through what you need to do in this session. And I have the slides for you here, but I will show how it is done exactly in this, like the slides. So before that, you need to have a Google account. If you have the Google account, what you need to do is you need to go to the Google Drive. You need to create the folder, and inside the folder, you need to upload all these notebook files. Then simply just right click and you need to select the Google Colab here. If this option is not available for you, because if it is your first time, you need to say that connect more apps, then search for Colab. So install this, and then the option will be available also for you. And for the overview of the notebooks, what you're going to do right now. So all the notebooks are self-contained, and it includes the tutorial and exercises. So here, how it looks. So for example, the Numpy notebook covers the overview of the Numpy, introduction to Numpy arrays, and the last one is the performing operation on arrays. So step by step, you will go through these notebooks, and you also have the exercises section which you need to complete. So this is what you're going to do for all the notebooks. And if you have any difficulties or any questions, you can also ask. But now I guess we are going to give you a time to go through all these notebooks. So this was the Numpy, the same for the Pandas. You have the tutorial and you have the step-by-step guide for the exercises. So you can see the exercises section here. So exercise the code here. So what you have learned in this section, you will do the exercises section based on what you have learned. Ajit, do you want to add something? Yeah.
Is there any order of doing the lessons? So for which one should I do first?
You can start any of that as much as you can do in the 30 minutes.
Yeah, so these are just libraries which help you to understand how Python works. So in this case, you can do them in any sequence. And like I said, one is about numbers, another is about data visualization, and there is no connection to the Scikit-Learn, but I guess last because I think the most sort of involved, but other ones you can do any sequence you want. So actually, you were saying something. Yeah, I thought it.
No, you're right. Yes, the Scikit-Learn was the hardest one, so you can just keep it for the last one. But you can start with Numpy or Pandas, but there is no issue with anything you want. You can start with.
So, so one more question, and then I will stop. So, so I have opened it in Colab. So if I highlight it and then just hit button, it will run the code.
So if you have all the codes uploaded on your Google Drive, you can do double click or you can do right click and you can do the open with Google Colab. And like I said, if that option is not available, you need to first of all connect to apps and install the Google Colab here first, and it will be a very quick, and then the option will be available for you.
Okay. Yeah, got it.
So at this point, what we need to be able to do.
Oh, okay.
Yes. Sorry, you need to be able to essentially
I understood. Okay, so
yes.
Basically, we have to read to that entire program and see how it executes.
Sorry, just say something.
No, I didn't say anything because it's echoing for me. Actually, I don't know why it's for everybody. showing for me actually. I don't know why it's for everybody else or not. Because I think that's why I closed it. So Aisha, can we give them about 15-20 minutes to explore the code?
Yes, and I'm here also to answer the questions.
Yeah, what we'll do now is 5:20 now from my point of view. So we'll give you about 20 minutes to explore the code, and then we'll come back and then we will take any questions from there. But meanwhile, we are here also if you need something, but mostly we will try to let you guys explore the code and make sure that you can do something. So Renuka, yes, yeah.
By the way,
can you please send that link again, that Colab link again, because I cannot find it in my
Yes, just I sent you all the Slack
No,
link.
it's not there. I can't find it.
So it is in the resources channel, and I will just post the link here, so you can see my post slides and codes for February 13. Under that, you will see the two files. So you need to download the zip file.
Yeah, I've done that. And
you've done that. So then you need to upload all the notebooks into the Google Drive under one folder.
Okay, I'll do that.
Yes,
Aisha, quick question.
Yeah, sir, this is Santosh here. So
go ahead, Santosh.
Hi, sir.
Hi.
Hi, everyone. So, hi, sir. So, I uploaded the files to Google Drive. I'm trying to find the Collab app, and I'm not sure where do I find that?
Oh, it doesn't come up to you? Like when you say the
No.
connect more apps?
No, actually, it's not.
Sorry, which browser are you using? I'm just suspecting maybe it is not coming up when you are using
I'm
another browser.
on Chrome.
Chrome?
Ideally, Chrome should be friendly with Google.
1 minute. Actually, we can just give them the URL. 1 minute. I'll just post it here. Hold on. Instead of connecting more apps, just a minute. Yeah.
Yes,
that's the
then let me, best idea. And also, let me do it open more for everyone.
Are you doing that on Slack?
And I will just post it here on the Slack.
Okay, sure. Varun, sorry, I think you had some questions. So.
Yeah, thanks, Santosh. Aisha, quick question. How do you run this? Shift Enter, right? Just like your regular children
Yes,
notebook.
Shift Enter, or you can hit the run icon on there, but Shift and Enter is the quickest one.
Got it. Perfect. Thank you.
So I think Fernando has posted the Collab link as well. So basically,
is that in resources channel?
Basically, that's the quickest way to get into the resource channel. We posted here on the chat. Here on the chat. On the chat.
I can
this
give me a
call,
second.
basically. Yeah. That's
oh, yeah, I see that. Collab.research.google.com.
Yeah. Oh, yeah.
Let me try.
So I have a question.
Yes.
I'm going through the Pandas now.
Yes.
So it is there is a statement from sklearn.datasets import load one.
Yes, Kwanya.
So what is that?
Yeah.
What
Yes.
is Scikit-Learn dataset?
Sorry, which notebook are you in? Did you say the Scikit-Learn or Matplotlib?
Yeah, Matplotlib.
So, sorry, what was your question? Are you asking what is the import statements?
Yeah, so where is it coming from?
Yeah. Yeah. So Priyanjan, at the moment, all we want you to do is run this thing. I mean, we want to know such a lot of detail at this point with it. But basically just an import of a library. So at this point, all we want you to do is just be familiar with running the code, because in the end, almost every session, you'll be running the code to the same mechanism, which is a call mechanism. But in each case, we'll go to the code later on and we'll develop it. But for now, the key thing is just to be sure that you can run this. But just to answer the question directly, you can, it's basically an import of the Scikit-Learn library.
And
Oh,
I also
okay,
just
got
want
it.
to add one thing. All these libraries are installed in the Google Colab. You are just importing those libraries to use in your notebook.
So I was able to go to Google Colab. Now question is, how do I access the drive from the Colab? I earlier imported the library, right? The 4 files to the drive.
Mm-hmm.
So
So
I'm trying to
what
see.
happens when you do a double click on the notebook in your Google Drive?
Notebook, okay. I'm there. It's saying untitled 01.ipynb.
Yes, when you do the double click.
Double click on which area?
Yes, sorry. For example, when you do the double click on one of the notebook.
Okay. Would it be easy if I share my screen?
Yes, if you are. Yep, please go ahead.
Give me a second. So bear with me. Okay, so I think you should be able to see my screen now, right?
Yes, it is. It's just
Okay.
coming up.
You see my Colab page, correct?
Yes. So where did you upload the files?
So I uploaded the files here. Give me a second. Bear with me. I have too many windows, I think. Let me show you. Okay. So if you see, I have the files here.
Yes. Can you just do a double click?
On any file?
Yes, any of the file. So can you just click on open with on apps on the top of? Can you say select more apps? Can you search for Colab? Not doubly, just one app. Yeah, this one. So you also need to install it in the first time, everybody.
Okay. So now it should work.
Yes. Can you just come back and try it again or refresh the page?
Sure. Thank you.
You're
Okay.
welcome.
Good.
Yeah.
That's fine. That's where we got. Thank you very much for that.
Yeah.
Thank you.
By the
I'll
way,
stop
all this is
sharing.
there. Aisha has posted this in the when we have the in the Slack. We posted a video as well, where you can see that. So the idea here is that we are just showing you something today, so that we are hoping that over this week you are going to go through this and also look at that. So thank you again, Aisha, for helping out with that. So Renuka, you have a question? Yes. Raise your hand.
Yeah.
Or was it from before? Yeah, I think you're muted.
So once you open,
Hi, Aisha, Ajit, I just had a question.
Anyway.
Is this recording going to be mailed to us?
Okay, so I thought you were yes, go on. Well, the recording will
Is
be
this
available
recording
to
going to
you.
be mailed
Yes,
to
I
us?
just need to check with Anand. Well, when you say mailed, it will be available. I just need to check how. That's the thing.
Okay. Thanks,
But
Ajit.
yes, it will be available. I wouldn't say the word mailed. It might be on the. We might post a link on the Slack or something like that. But I'm going to try and yeah, so it'll be available to you. Yes. But mainly that this week has posted, and also go through, make sure that you can run it in Colab, because I shared also posted some videos where you can see them on the Google as well, just to see how Colab works. It's really very simple, and it should be very easy to run it with that. Cool. Okay, so there's a question here from Vinny. Are we trying to run the code and get some output, or just go through the code? So Vinny, so at the moment that we are just trying to run, but at the moment, literally now, we just want you to get used to Colab, just the way of working. There are some exercises where you have to complete the code. So the long question is that, yes, over this week, we are expecting you to actually run it and complete something with it if you can. But literally, as of now, we are just trying to make sure that you can run it and you are just able to see something with it. Cool. Okay, so what is not working, Renuka, with that?
Actually, my son is not able to download that thing. He has opened the collaboratory, but it's not able to manage to do that actually. Can you please again show the how to do this basically?
Well, technically, if you just have a Gmail account, it should just work directly from
Yeah.
there. Yes. So literally, if you just will do that Google thing, you know, that link which was posted just now by, I think, Marco and me as well. This link, yeah, Franco, yeah. So this link, if you just post it this way, from here, it should just work with this. But it is entirely browser based. That's the beauty of it. There is no other. Yeah, Farid, yes, please. You have a question? So Renuka, just try it out. And let us
just
know,
one. Hello. I
Yes.
just wanted to say it's easier to unzip it on your drive and then upload the folder, because if you try and unzip it inside Colab, it doesn't work.
Yes, you need to unzip first of all.
yeah.
You need
So
to
what?
upload each of them.
Yeah, that's a good point, Farid, actually. Yeah. So what I would do is download the zip, unzip it on your drive, and then go to Colab,
Yeah.
like the link I just posted, and
So when you're
then
in,
open it.
sorry to interrupt you, when you're
Literally
in
with the
Colab,
file with that.
if
So
you
open
right click, there's an option to upload folder.
Yeah.
And you can upload the entire folder.
Yeah, but this is why I'm trying to get people to do it the simplest possible way. So this is why I said that rather than uploading the whole folder or something like that, upload it one by one and it should work.
Or you can
with that.
or you can
Because all we are
upload the
trying to do now,
files individually.
Yeah, and that's exactly why I said that. That's what I said that to Renuka as well. The quickest and the simplest way is that you go to the browser and do it that way, and then unzip it on your drive, like you said, for it, and then file open one of that. So Aisha, you're presenting something, or you stopped presenting? Sorry,
Yeah,
you
yeah,
stopped.
yeah. It was a
Okay,
mistake.
sorry, yeah. So Saif, yes, all good for you. Thank you. Very good. So yeah, I mean, it should be very simple. And the goal now is just to make sure that you can basically get some familiarity with Colab. The reason why we're trying to do that is because all the code is using Colab. So the rest, every session will have code, and all of that will be based here. And the reason also is this week, we are hoping that you can go through these 4 notebooks and maybe post some questions with that, because that is our objective as well. You start to learn with these things, and then once we go to end of next week, we'll share with you all the algorithms, which are the ones we are doing in which week, and that's how we will work with that. So every week we will be working with one algorithm in Colab, and that's why Colab is so important, because what we'll then do is go to an IP, and I go to a library, sorry, go to what am I saying, a notebook, and open it, and then run a specific algorithm for that week. So for example, you'll be running a regression algorithm for the housing prices, then you'll be running a classification algorithm for the cancer detection, and so on and so forth. Then you'll be running deep learning algorithms, then you'll be running with fashion MNIST, which is another data set. That's why Colab is so important, because if you spend some time this week just making sure that you can run it, just these notebooks, that will be extremely useful with that. And Saif and many people have already got it right, which is great. And if you spend some time at home, you can easily get it done as well. So Pratik, if you are running a specific cell, not as make sure that numpy is import numpy is np. Yeah, okay, that's fine. Thank you. Yes, you'll find all these little things and you can go with that. Yes. So any more questions here so far? Thank you, Aisha, first of all. Yes, I think thank you with that.
Thank you, Ajit.
Yeah, thanks for that. So what is the question, if you don't mind me asking, by the end of this course, what is going to be a main takeaway? So the main of the main takeaway here is that you'll be able to run a series of algorithms and understand them completely. This is the answer to Vinny's question. So this is what you're doing, is you're running a series of machine learning and deep learning algorithms, classification, regression. I think then there is one MLP algorithm, one CNN, something like that. That's the key takeaway within that. Hope that helps your question with that. So Prashant.
Hello, Ajit. I just wanted to.
Name tag a little.
Can I ask you just one? So
Yeah, go on.
I'm just going through the libraries of this Pandas and Nymphy. So this over the next period of next week, are we going to supposed to go to this library and get familiar with all the functions that are available in the library?
Not all the functions, no. I think we are just broadly expecting to get you familiar with running the ideas and running the code with that, because I think that you wouldn't be able to get familiar with all the functions. We just want you to understand what those 4 libraries are, because they are the core libraries, and that's just the libraries. Yes, that's not actually running a model. That is just a library which allows you to do things, and that will give you some familiarity with that. So I hope that answers your question with that.
Okay.
Ashwini, yes.
Hi, so I come from a software engineering and application development background. So my question is similar to the entire life cycle of the machine learning development projects. So we have in software engineering, we have phases like design, development, and then we do testing, and then we do production deployment, etc. So how is the framework defined for the machine learning projects?
Yeah, so that was the one of the diagrams I had with a few times there. Sorry, excuse me. But I sort of, the first phase is exploring data, as what Aisha was talking about. Aisha also had a similar diagram. Then you have some hypothesis testing. Then you have some feature engineering. Then you have some model building. And then you have model deployment, and then you have your model evaluation and model deployment, something like that. So if you see my slides, you'll see that framework right from the beginning with that. So broadly, that is a framework with that. But of course, in practice, it's a little bit more complicated, but the simplest structure is what we have described with there. The main complications in practice are to do with if you use big data, for example, then you are doing something around Spark or Hadoop or something like that. If you're doing DevOps, then you're putting things in Docker containers and deploying them on containers and things like this. So that's a complexity behind that, the computer science element. But the basic Python the pipeline is pretty straightforward. Yeah.
But then, as we said, right, the model keeps evolving, or we keep modifying the algorithms based on the more data that we get. So after the machine learning project is in production, if I come from the software engineering field, so even after that, once we start getting the production data or the actual data, then also we keep on evolving the models, or keep writing new algorithms in that case.
Yes, so basically it's not writing new algorithms, it is basically retraining the model. And the way you do that, if you want to Google things, Google word ML ops, yes, ML ops. So it is the mixture, the combination, the word ML and DevOps, machine learning and DevOps. Yeah. So what you're doing there is just like you're doing a classic. So this is what Aisha and I do both in our work, i.e. my company, and also at Oxford. So you do a typical combination of CI/CD. Yes, so you do a CI piece, which is the continuous integration, and you do the CD piece, which is the continuous deployment, and also you have a CT, which is the testing. So you do the CI and CD, and you deploy it into production, and you do a testing against that, and you test the accuracy, the accuracy of the algorithm, and then you have to retrain it and push it back in the pipeline. So basically, the word you should be looking at searching for is MLOps with that. But this is the, as you rightly said, this is the more production way. So what we're talking about today is more about sort of the core algorithms within that.
All right.
To answer your question?
Yeah.
Cool. Thanks. Yeah. Good. So we'll let you guys just sort of play with it for another 15 minutes or so if you have any questions. Otherwise, I think, Aisha, do you have anything else? No, isn't it?
No, Ajit, that was it. We can take the questions if they have any.
Yeah, cool.
Ajit here,
so Farid, yes,
here. Can you hear me? Can you hear me?
Hello, Aisha. I've just tried running Numpy, and while you're importing NumPy's NP, it doesn't seem to like it. So I've tried running the first bit, and it doesn't know what NP is. But I don't understand because you've defined NP further up.
Sorry.
So the first thing you do in that piece of code
NumPy as
is you import NumPy as NP.
Yes.
Which is fine. And then if I scroll down to the first piece of active code, which is A equals np.array, open round brackets, open square bracket 0, 1,
yes,
2. If I try and run that cell, it says it doesn't know what NP is.
Okay, let me try quickly. It doesn't say for me. So did you run the code?
Yeah.
First line, did you imported the NP?
Just make sure that you refreshed your window and you run the code before coming across to the other cell or run it again.
But the thing is, that's the first piece of code that runs, so it should run no problem.
Because NP is just like an abbreviation of using NumPy. We're so silly, we don't want to write NumPy and every time we want to use a function.
No, I know why you're doing it. I'm just saying it doesn't run.
Just make sure to refresh.
Yeah, I think I also get the same. I get an error for name error. It says name NP is not defined when I run the code.
Hold on, I'll paste what I'm seeing into the chat.
Can you also share your screen and show us?
How do I do that? Hold on. Bear with me a minute. How do I share my screen? Sorry.
So there is an icon, like when you raise your hand, just next to it, there is one more icon to present. From there, you should be able to share your screen.
Bear with me a minute. Sorry. Turn on captions. Is it presenting? It's not presenting.
Yes, it is a presenting one.
It's a two-step process. Once you click on present, it will ask you which screen you want to share, and then you click on the screen and then present.
Oh, what's it doing? It's not letting me share. Sorry. Hold on. Let me just paste it.
I don't think.
That's what I'm seeing.
I think you need to import the NP. You didn't run the code. That's the reason. Can you just run the first cell again? And can you just...
I did, but the code is, the import is done further up.
Yeah, but you need to run the cell. Yes, did you run the cell?
Sorry,
yeah, that's what you need to do, because without that, it wouldn't be able to know that you have run it. So it's
sorry, I don't use
notepads. Yeah, but I think that this is exactly why we want you to spend this week a little bit actually making this run, because that would get you sort of understanding that, and this possibly the same problem with somebody else as well who posted.
Yes, just you need to run the first cell. If you just go up.
Yeah. Let me try it again, and I'll tell you whether it's worked.
Cool. Okay, good. So there was somebody else who raised their hand here. What was it? Who was it? And that is gone with that.
Yeah. Pushpa here. I am sharing my screen.
Yes, I'm seeing your screen. Can you just go up to the first line? Go up. So here you need to start with importing the Numpy as NP. So you didn't run this cell. That's the reason you are getting the other errors.
Okay.
So if you go back to your errors, you will see that it should run.
So one question I saw here, like on this, once you run the command, where does it show the output? Because on Visual Studio, I have seen that it shows in the bottom of the video, it will open a separate section to show the output. I have like few different tabs about diagnostics. How does it work here in the book?
Yeah, I just showed you the link, the line below it. You can see. So when you run the cell, the thing below it shows you the output. So obviously, when you just import the library, there is no output. But if you actually ran something which had an output, it will show you in the next cell below that.
Yeah, I have pasted one screenshot from the bar. Can check.
Cool, pretty good. Yeah. So Renuka, yes, you raised your hand here.
In the chat.
Can I also do this in a Replit? That is much more easier for me.
Sorry, in what?
In Replit. In Replit. I will just paste the link in the chat. 1 minute. Because it's much more easier. Otherwise, it becomes very hard.
So what is Replit? Is that a browser? Is that
IDE?
Never used it. I don't know.
Yeah, I mean, if you can make it run, I don't mind, but we can't support it. We don't know much about it. I mean, there is nothing other than Colab. I can tell you that.
Because I'm new to that, and I've been doing Replit for over a year now because because Python works on it and I do it. So.
Okay, we don't know Replit, but if you run for it, that's okay. So Ridwan, yes, sorry, will all the terms like regularization, statistical learning, or we explain later. So this is exactly why Ridwan, we have explained some of those. We have sent you a glossary, which is there. So one of the things with machine learning and deep learning is that you need to learn a lot of terms and understand a lot of things. However, we will explain them as they come along later on with when it applies to the code within there. So many times, so this is where we are expecting you to post things which you don't understand, but also look at the glossary. That's why I posted the glossary as well in the resources channel. And that's why the glossary in many cases should be able to sort of get you about 90% of the answers. And that's what we hope with that. I hope that answers your question with it. So Kanad, yeah, so please.
Kanad, yes.
Kanad, please.
How can I get the function definition in this?
So when you want to understand a particular definition of something, you normally look at the Python library itself, or the TensorFlow library. So what you're looking at really is to look at the documentation of Pandas and things like that, which is fairly easy to find out on the web, which you should be able to do. I can so that as well. You should look at Python documentation, basically. If you just Google it on the web, just straightforward open source work. Python is the Pandas, so it is a standard library in Python. If you Google that directly, you'll be able to find it. Hope that answers your question.
No. I was asking like functions means if period series, so what its series does, or period date range is there. So I want the definition of the date range, what it does, or what are the inputs it.
Yeah, but even that also you can find it. Just find it.
Okay.
PD is Pandas, yes. So that's what I'm trying to say. It's just like looking at API library within that. So you should be able to find it straightforward by looking at the Pandas document within that. Cool. So Santosh, yes, yeah.
Yeah. Am I audible?
Yeah, I can hear you.
Yeah. Okay. So can I share my screen for a minute?
Yeah.
Yes.
Yeah, I'm doing that. Right. So I have reached up to this stage. Okay. I opened this one in Colab. So how do I run the code here now?
Yes. So you can hit the run button on icon, or easiest way is you can yes, you can run using that one, or you can use the shift and enter. So it will run the code. You can just press shift and enter together. It will run the code.
Yeah, and also Aisha has posted some videos when she has in that zip file and the slides with that. You should be able to learn pretty much how. Yeah, in the slide there is the link to a video. Very easy to learn how the basics of Colab works with that.
I will. Cool. So I have run the code. So where can I see the output, or what happened with it?
So the output in this case there isn't an output because you just did an import, but later on when you run through each of the cells, you'll see the output just below the cell, because if you just import something, there is no output as such. Yes. So, but when you run those cells later on, you will see some output just below the cell. Yeah. Cool.
Okay. So today's
there. See, you can see it now. See, I can see it on your screen.
Yes.
You have an output there, the white thing. Yeah, that's right. Exactly. Yeah. Cool.
Cool. Okay. Thank you.
Okay, thanks. Yes. So I think we've wrapped up for today. I think we've covered everything we need to for today. So thank you very much. Thank you again, Aisha, for presenting this. And again, this will be the format we will follow, which means that we will explain the concepts initially for something, and then we will go and look at the code and run the code every day with that. That's why the Colab stuff is important. And if you spend the week just going through the libraries, just making sure that you understand them, at least broadly, I think that's the main thing. So Aisha, do you want to add anything more?
No, Ajit. So yes, if you have any question, just reach out in this Slack and we will be online there.
Cool. Very cool. Okay. Thank you very much. So we will meet again a week from now, and we'll continue in the same direction with classification, regression, and things like that. Again, I'll explain concepts first, and then sometimes I'll explain the concept a little bit ahead of very good, and then we'll go from there. Okay, thank you, Sai, for the good words. Thank you for the work with that. Thank you, Aisha, as well. So
thank you very much, sir.
For your good work.
Thank you.
So yes, for your good.
Thank you.
Yeah.
Thank you, sir.
Everyone. Thanks, everyone.
Thank you. And we'll post you about videos and so on with that. Thank you.
Thanks, Ajit. Thanks, Aisha.
How are you doing? Bye.
Thank you. See you.
Thank you.
Thank you, Mr. Jaokar, and thanks, Asa.
Thank you all for your time. Thanks.